Okay, today I will talk about the startle response behavior and its factors. Okay, introduction. And first, you may ask what is the startle response is. So the startle response is the unconscious defensive response to the startling or dangerous stimulation. It is a kind of pre-defensive. So let's go back to our topic and why choose the startle response to do the research. About the integrates, only a few studies are about pre-defense. Most of the studies is about the variation in prey and predator's dynamic. Okay, and predator and prey interaction have long been seen as a fundamental component of animal ecology. This is the major driving force to the ecology and the evolution of biological systems. And next point is to see the global warming will make a big impact on this species, even our ecosystems. Okay, this is a bivalve startle response. It's easy. Just when bivalves confront the stimulation, and it will be close its shell to prevent from eaten by the predator. And this is our goal of this studies, to assess aspect to relate to the behavioral ecology of bivalve startle responses, and we want to test the combined effects of pH and temperature on the bivalve startle responses. Let's talk our applications. First, we think the startle responses will be repeatable, and the time to open will decrease over time due to the factor or habituation. And next one is large animals would have a shorter startle response. Because large animals, we think that has less chance to being consumed by the predator. And next is about temperature. And because higher temperature will increase the metabolism rate, so the animal need more oxygen, so they will reduce time to open. And next one is the low pH will affect the startle response. Because many reports say the ocean acidification can make big impact on the animal behaviors, so we think it will impact the startle response also. Okay, actually the last 2 points is out of our predictions. I will give you some evidence in later talk. Let's talk about our method. Our experiment is designed in 2 temperature levels and 2 pH levels in order to simulate the different conditions in our ocean. So, and it is crossed in a fully factorial manner. I mean, like this. So we can study the effect of each factor and through these 4 treatments. And our experiment is conducted in this area. And you can see the muscles and just bivalve in this chamber. Okay, this one talks how to we conduct these assays. First, we use the stick to touch the mental tissue until it curls. I mean, there is the mental tissue, and we use stick to stimulate and to record the time they reopen with the stopwatch. Next, the process was repeated over 4 consecutive trials. And let's talk about the result. about the effect of size, and you can see the relation between the time to open and the size class. And the gray one is the small size, and the large one, orange one is the large size. So you can see the small monsters have a longer time to open than the largest one. And about temperature, and you can see y-axis is the same, and the x-axis is the temperature. A blue one is low temperature, and a pink one is high temperature. And you also can see the higher temperature has remained closed longer than the low temperature. And next is the effect of pH on the time to open. And you can see y-axis also is the time to open, and x-axis is 4 different treatments about our experiment. And according to this figure, we conclude the pH seems no significant effect on the time to open. And let's go on to the repeatability. The most important thing in this figure is about this R value here. R value was estimated to be 0.56. So we based on the statistic method, when the R value larger than 0.37, we denoting that it has significant repeatability. Okay, let's go to the discussion. At first, we predict that high temperature will increase the metabolic rate, so the time to open will be decreased. But on the contrary, to our prediction, elevated temperature increase the time to open. So we think the possible reason is that also will increase the endothermic predator activity. It means the muscles have the more chance to be eaten by the predator because its activity also increase. And next is increased metabolic rate. It will increase the detectability. And because when you increase the metabolic rate, animal will breathe more and will emit more CO2, which is chemical signal can be detected by the predator. So it also will increase the detectability. Okay, that's about pH. Many reports that they will have big impact on the ocean, on the animal behavior by the ocean acidification. But actually, in contrast, we observe there's no effect of low pH on the time to open. So we think the impact of the acidification seems to be overestimated in the animal behaviors. Okay, let's talk about the animal size. The smaller muscles are more vulnerable to the predation than the larger ones. It means small muscles will have a longer time to open to prevent from ate by the predator. So we think it is time to open appears to be at least partly detected by the relative vulnerability. And let's go to this topic. We can see time to open linearly decrease as the trials progress. So we can suggest that its habituation is more likely, not because of time. So because the animal has the ability to strike a balance between the risk of being consumed and the energy intake. Okay, this is about repeatable behavior. In our experiment, we see a high degree repeatability in the time to open. So they can provide for useful role model for behavior ecology. And this one is about the community levels effect. Our data suggests high temperature and high predator activity will reduce the food intake of the bivalves, and so also influence ecosystem benefits. So we concluded that it is possible that ocean warming will influence the benthic system worldwide. Let's talk about my conclusion. And conclusion about the Startle response is highly repeatable and present the site of habituation and unaffected by low pH condition. That's why the time to open can be negatively affected by elevated temperature. Okay, this is our future prospect. We wish the future would have the studies that can quantify the effect of warming on the ecosystem supplies. Okay, thank you for listening.
So in one of your features you mentioned the R value. So I want to know how did you get the number 0.37?
Repeat his question.
You know how do we get R value? Because I think the statistic method was so complex, so I didn't expand more to the details, because this is most important is about to prove the repeatability is significant. So I just put the R value in even larger than 0.37. So I didn't see the detail about this.
Okay, next.
I want to know the different size of the muscle will really affect the open rate.
What is it?
Read your sentence again. Ask the question.
I want to know the open rate. The open rate will affect by the different sizes of the muscle.
It's a different range open by the size of. Okay. You can see the size class. The gray one means small, and orange one means large. So why will have this result? We think because smaller muscles it have more chance to be ate by the predator, so they want to close for longer time, so it can prevent from ate by predator. So large one have less chance, so will cause this result.
According to your research result, what do you think is next research for something? Okay. Okay. According to the result of your research, what do you research for next?
For what?
Repeat.
For what?
just next topic, what do you research?
Based on your results, what do you think? What should you do next?
What should we do next?
Future research.
And about our future research, we think to quantify the effect of warming is very important, and because it can, so we can have more information to start about this phenomenon or this topic. Yeah, just quantify. This is very important.
If the muscles die in the test, the data will some error or not.
Okay.
Repeat.
If data was dead and what?
In the test, the data will some errors or not.
Okay. The data dead. If whether there will be some error in it. Actually, in this experiment, it have the data was dead. Originally was 120 samples, but when they died in the experiment, we just to remove the data from the analyze.
All right. So I think there are several good things about Reynold's presentation. The first thing I noticed, I'm sure you also noticed, is his slides were very easy to read because, for example, he had this really large font. Take a look, so 28, and he had short sentences and color-coded keywords. So whenever I'm lazy, I just read the keywords, then I can follow him. So it's a really nice thing to do. I would suggest you to do that too. And he also spoke very fluently. You saw that he was really doing things like this. So you had the feeling that although he was not really looking at you all the time, but you had the feeling that he's not really into his own world, but instead he was trying to communicate with you. So that's also very nice. Then let's talk about what he can further improve. So for example, I think he might want to spend more time explaining some difficult terms, especially with images. For example, the term startle can be actually very easily explained with image. So it's better whenever you can explain something with image, you try to do that because it's easier. It's easier to leave an impression in the audience. And there are several words that he should explain. For example, there's a prediction. Okay. For example, like there's a pronunciation error. How do you pronounce that? Fatigue. This pronounced fatigue. So you should try to explain fatigue, ideally with image. Image is worth 1,000 words. So try to use image and also try to explain habituation. And also there's a simple words used, but I'm sure some people don't know what that is. So for example, here you talk about stick. Maybe some people don't know what that is, so you can easily add an image here so we know what you're talking about. And then there's another word called ectothermic. You know what I'm talking about? No, you have to explain that to the audience, not to me. Sure, use image. And then he had a very nice purpose slide. Yeah, so I don't show that. Yeah, and in addition to the purpose slide, he had a prediction slide, which is actually his working hypothesis, 工作假设. It's always nice to have this kind of slide, but whenever you have this kind of slide, I would suggest that when you present your result, you always bring us back to your prediction first, because you have many predictions, 4 or 5. And after this slide, we already forgot your prediction. So whenever you present your results, it's always good to tell us, okay, what's your prediction first? And then what's your observation? And then in your presentation, you have separate results and discussion. That's something I would avoid, because after you present all the data here, and then going back to your discussion, I already forgot your data. So your discussion should always follow your data right away. Otherwise, our memory is really, really short. So try to do that. And right. And it's nice that you have this concluding sentence. Yeah. All right. And then when you have this, when your talk have this prediction slides, it's always good. It's actually a kind of skill here, presentation skill in your conclusion. Where's that? Where's your conclusion? Can you show that? Conclusion slide. In your conclusion, it's always good for you to not using these new sentences, but instead reuse your prediction slide again and say, if this prediction is confirmed, check. If it's not, cross. Then there is a sense of coherence, 就是一致性 in your talk. So we know you are really proving your working hypothesis. Okay? Okay, but overall it's a really nice talk. Let's take Reynold. We are taking a break.